Rail Up, the future mobility podcast with innovators and leaders of the ecosystem. Presented by Sebastian Sperker.
In this episode, we're talking about that big game changer in our time, about artificial intelligence. Our guest today is Michael Küpper. He is an extensive expert in AI and working for Deutsche Bahn. And together we will explore the fascinating world of AI. Michael will talk about AI basics and of course about the big use cases in the ecosystem of rail. So let's join me and let's begin. Hi Michael and welcome to Rail Up, the podcast. And as the audience know, we start our podcast always with the same questions. Michael, are you rather a leader or an innovator?
Let me give you a typical physicist answer. I see myself as 60% innovator and 40% leader. The two are sort of connected for me. I think leadership always needs a purpose, and innovation is a purpose, a strong purpose. And innovation itself does require leadership, because that's the way to get it out there into reality.
Okay, thank you. And then let's start with a fascinating topic. Our topic today is AI. And in the past 2 years, AI has to become one of the most significant topics of our century. And many of us frequently uses now ChatGPT, or almost every day you can read about new breakthroughs in this field. And to deepen my personal knowledge and understanding, I attended an AI bootcamp and I explored this fascinating world. And what I learned there is basically that our AI is super expensive. Most of the projects are failing. And moreover, that if we consider AI applications, we rather talk about automation. And the answer of AI is always AI. And and also to give us now a better overview, Michael, I would ask you can you give us a brief overview about AI? And then let's deepen into what AI and which powerful application we can have in rail.
Well, there are many definitions of AI and they are partially contradictory. So let me add my own one, especially for the purpose of this discussion. So first, a disclaimer, what is AI not? We're not talking here about general artificial intelligence that can really replace human intelligence and create its own purpose, set its own goals and things like that. So I think we are very, very far from that. And chances are we might never even achieve that. But that's not what we're talking about. When we're talking about artificial intelligence here, we mean machines usually implemented in software, usually implemented in artificial neural networks, but not exclusively ANNs, machines that can sort of learn their own behavior, learn strategies, that can tune themselves in order to solve a given specific problem. And that can be done in a supervised or an unsupervised way. I'm sure we'll get into those differences later on, but it's briefly a machine that can learn by itself to solve tasks.
As far as I remember, in the current state, we're always talking about the so-called weak AI. And in comparison to strong AI or even the super AI, the applications today don't have an own mind and they are designed to solve like a specific problem. And AI is used in various sectors. And when it comes to the mobility world, we often hear about AI for autonomous driving. And in the rail, especially about predictive maintenance of infrastructure parts or of the rolling stock, such as locos and wagons. But on the use of AI, you and your team are working on has a different focus. So tell us more about it and which problems you're going to solve with it.
Yes, as you said, Sebastian, there is a lot of AI being used in many sectors, including in the railway sector. I'll definitely subscribe to the view that predictive maintenance is already done all over the place. And when we're talking about such examples, such use cases, then we are usually referring to what I would call classical AI. So this type of AI is good at pattern recognition. It started with the classic example of machines learning to distinguish a dog from a cat in a picture, and then it gets more sophisticated, face recognition, reactive maintenance, discovery of some irregularities in parts of equipment, down to predictive maintenance, where machines learn to predict the near future based on patterns that these systems see in a bunch of data. And that is all pattern recognition. So let's let's call that classical AI, because it's been around for many, many years and has been driven to a fairly high degree of maturation. Then there is the type of AI that we are using in my team at Deutsche Bahn and elsewhere, for example, in autonomously driving cars. That is real decision-making AI, where AI learns to control a system, be that a car or something else.
In real time, right? More or less.
And usually in real time, not necessarily, but of course, these are very interesting use cases. So that's what we are doing. In my team at Deutsche Bahn, we've spent the last years trying to tackle one of the most fundamental problems of rail operation, and that is capacity and traffic management. And the system we're building is therefore called a Capacity and Traffic Management System, short CTMS. So that is the machine, sort of a central brain of a future highly automated, highly digitalized railway system that decides about which train should ideally go when and where and in what order, and what to do if something happens, something other than planned, how to change plans in order to re-establish a plan that is as good as possible under the given circumstances. So that's CTMS in a nutshell.
And the CTMS is your field. And now let's dive into the specific use cases. One of the major challenges are if a specific stretch is unexpectedly close because of an accident or a tree on the tracks. And now AI comes into the game. And in our pre-conversations, you told me that you take various considerations into account to find the best way under new circumstances to operate the trains with the lowest impact. You even have an eye on not creating a new energy peak. So in other words, it's a huge holistic approach.
Yes, indeed. Our approach is holistic, because in a railway system, you quickly come across effects that could be described as kind of a butterfly effect, that from deterministic chaos theory. So something changes, a little bit of a delay somewhere in North Germany near Hamburg causes far-reaching effects hours and hours later down there at the Swiss border in Basel. And that's what I mean by butterfly effect. Because if one train doesn't really hit its planned slot, another train is certainly affected, and it affects a third and a fourth train, and so on and so on. And especially if you have this example that you already mentioned, Sebastian, you need to reroute trains because of a blocked track. So you reroute them, let's say, to the parallel track for the oncoming traffic. So that affects the oncoming traffic. Traffic starts to back up. Maybe you find some rerouting opportunities for trains that do not have to adhere to commercial stops, like cargo trains. You can put them on the side route.
Don't say this, please. That's really hurting. Putting trains on his
yes,
side. Yeah.
For you as a cargo person, yes, you put trains whenever possible to other routes and delay those trains, which then becomes a question of negotiation with the operators, whether there's some refund and so on and so on. But you said, I just want to make the point, The problem gets very large. So mathematically speaking, we're talking about a so-called NP-hard problem, a problem that cannot be efficiently solved with existing classical analytical algorithms. Otherwise, it would have been solved already, especially after the 1990s, when classical mathematical optimization became really a tool for industrial use, mainly in aviation and other transportation areas, with the rise of computing power in the 90s. Of course, the algorithms had been there before, but the computing power made it accessible then. But still, for this type of railway butterfly effect NP-hard problem, these algorithms are not enough. So here's where AI comes in. Just before we started, and that's of course not a coincidence, Google's AlphaGo and AlphaGo Zero happened, 2016, 2017. We're talking about the computer that learned to solve the Asian strategy game Go, which is by many orders of magnitude more complex even than chess. And the machine did what few experts thought was possible at the time. The machine learned a strategy to play Go and was ultimately able to beat the world champion Lee Sedol in the game of Go. And that was kind of a revolution. So the thought was there, can we use that AI breakthrough, this new type of AI that does not do simple pattern recognition, but that can really learn a strategy, make decisions, come up with something creative? Can we use that for the railway system? And yes, short answer is yes, it is possible. We did that. We built a prototype based on, in short, AlphaGo 0 for the railway system, which again is way more complicated because rail is not a 19 by 19 board with squares and black and white pieces. It is way more complex, yet it is possible. And the main promise so far holds true. These AI models that we build to solve typical railway operational problems, they are efficient, meaning you can scale them to larger problem sizes without running into this exponentially growing processing time.
How long it takes, like if now like one specific track is blocked and you have many trains running by that are with AI and under and if it's really working, the application, how long it takes then really to take an action and to recalculate the entire timetable for hundreds of trains?
So that depends, of course, on the size of the network, the complexity, the structure of the network topology, and the number of trains. In our modeling, mainly the number of trains affected. And I can quote this here because it's been published in industry conferences already. For a setup of a typical German network node with average complexity and size, and for 1 or 2 operational hours with 30 to 40 trains, the system can come to dispatching decisions, meaning it can rearrange the live traffic in near real time in processing times of way under a minute, talking here 10, 15 seconds, something like that.
Fantastic. I mean, like just taking all these variables in consideration, then with less than 1 minute, you have like a decision how you go further and really in a really optimal case, how you can do it. And sometimes like the effect is then not too big if you really take all the considerations into the calculation, right?
Yes, because the system works really in a holistic manner, meaning it looks at all the 40 trains that are in this node that need to be rescheduled. And it's within those 10, 15 seconds, the system comes to a setup of new schedules for the existing, for the running trains, based on where they stand and how they drive at the given moment after the disruption occurs. That guarantees smooth traffic afterwards and minimum deviation with respect to the original schedule.
And we're talking about the new world where everything is connected with everything, but therefore you need probably everywhere like ETCS, so heavy investment in infrastructure and in the rolling stock. But do we really need to upgrade the entire ecosystem, or can we use the application in a kind of a standalone mode already?
Well, short answer, of course, you need all that. So, but let's say if we at Deutsche Bahn or someone else out there comes up with this machine full-fledged that can make plans in relatively short time, you could use it for planning, and then it doesn't matter how the plans are executed. So that's one thing. But if you want a system that can actually implement its own plans via direct digital access to vehicles and the infrastructure safety system, then yes, you need interfaces and you need automated systems on the other respective sides. So that includes a way to talk to the vehicles and let the vehicles automatically execute those plans. That's ATO, automated train operation. And you need access to that safety system.
Okay, so we next to the infrastructure, we also have like various elements which has to be also upgraded on a technology level that the interaction really works together.
Yes. So on the infrastructure side, you already mentioned ETCS. Yes, that is the current hypothesis that ETCS gets rolled out also in Germany, in France, and elsewhere, and becomes the standard digital train influencing and safety system. Of course, ETCS together with some kind of digital interlocking. Yet some of my colleagues at Deutsche Bahn, at Digitale Schiene Deutschland, I have to say, the part at Deutsche Bahn that is tasked with such innovations. So colleagues at Digitale Schiene Deutschland are working on something beyond ETCS, or let's call it a higher generation of ETCS that would use some technical upgrades and simplifications and introduce a fundamentally new view of interlocking away from traditional fixed blocks to dynamic moving blocks so that trains could really go after one another at braking distance.
Without signaling anymore.
And obviously without signaling. Yeah.
And can you also provide us some insight about where you are with the project right now? What is a little bit of timeline? So when you will test the first AI application, and in which size?
As far as the larger timelines are concerned, there's a lot of debate going on right now about the appropriate funding for these initiatives, including the dynamic moving block safety logic that I just described. So as I am not officially authorized to speak for Deutsche Bahn, it's a little bit difficult to speak about timelines in this conversation.
But we don't talk about that this will be let's say in the next 1 or 2 years. We're talking about 5 to 10 years, right? It's just
yes, of course. That's that much I can say. We're talking about long term because, as you already mentioned, this requires not only upgrades to the infrastructure, but also upgrades to vehicles. And all this not only takes time, but it is, of course, a team effort in the entire railway sector. So this affects the infrastructure manager, obviously, but it also affects all railway operators, of which just here in Germany, we have actually a couple of hundreds operating trains on our infrastructure.
Well, what you tell me that from infrastructure perspective, you're pushing the applications through, which is a really good thing. But on the other hand, we also have to be clear that we also have a lot of other players, which they need also to justify or upgrade their system, their vehicles in order that is really together. So it's not a one-man show of DB infrastructure. So it's much more, you need really to upgrade the entire ecosystem, and that more or less in the same timeline, right?
Yes, and that's one of the reasons why the timeline is rather 5 to 10 plus years and not short term. However, there are things, and this much I have a lot to say here, there are things that we can achieve on the short term with the AI-based system that we've already built, and that would probably be in the area of planning, scenario generation. Use the system and its capabilities to think through what would happen if I would add an additional track here, or a set of points there, or maybe a new bridge or a new tunnel. How would that look like? I mean, with traditional and currently existing simulations, you can of course simulate all that, but you don't have a generator that can quickly generate schedules for such a hypothetical scenario. So this is something that is already possible today, and I think the first users will be using this capability rather soon, meaning in a matter of months or years.
Okay, sounds cool. And actually, I was just thinking, because you mentioned to put the cargo train on the side for the sake of a passenger. Basically, if the AI is learning, basically, is it also kind of biased then to to rather give the passenger priority?
Well, yeah, here's where artificial intelligence reaches its limits. It learns whatever we teach them.
Okay. Yeah, so depending who teaching them, and
Exactly.
and what we also heard in the podcast quite often, because AI needs, I think, what in order that the application working properly, I think it's need clean, structured, and centralized data. And these three topics are something which I learned in our railway world. It's sometimes very difficult because you have a lot of legacy system, you have a lot of different not structured data because of organizing everything over the years. So what is your biggest challenge in order to get this through? Is it the data topic, or what do you see? What is needed really to be addressed to have a successful and not to be heard about a failed project? Because like there is even a number like that 85% of all AI applications are failing, right? I mean, that's quite more than a majority. And so, yeah, what's your biggest challenge?
Yeah, I think that sounds plausible. I haven't verified that number in detail, but it is plausible because many projects, not only AI projects, but data projects, data science projects in general, have a hard time succeeding, and that is usually not only in railways, not only at our company, but in a lot of companies that I've seen. I've been a management consultant before. I've seen dozens and dozens of companies. Usually, the problem, as you already mentioned, lies in the existing data infrastructure and in the legacy system infrastructure. So the data are usually not clean. They haven't been collected and stored with this kind of automation and data science in mind. It's usually distributed across a number of systems, some of which were built at a time where you don't even have the appropriate developers anymore who are familiar with the languages, the programming environments that were used at the time. So these are some of the hardest problems when it comes to any kind of data science and or AI project.
Okay. And what I would be interested in, I mean, you were like quite from the beginning on the project. So basically, let's say I have a company, a railway company, whatever, and I have a lot of money and a high interest to start to solve a problem with an AI application. I mean, how such a project starts? I mean, you have a business case, and then you start to hire people, server, or whatever. It's like, what is sort of the typical journey how you get such a project started?
Do you want to know how the project actually starts or how it should be started in order to have a higher likelihood of success?
Well, what was your journey?
I've done that before.
Okay.
And I've been through that, done that. And of course, we ran into some of those problems we already started talking about. So usually it starts with someone having a great idea and saying, hey, if we just use all that available data and we use state-of-the-art algorithms and we use state-of-the-art computing power to actually implement those algorithms and let them do their job within a realistic amount of time, then we should reach some kind of insights that can be used for business, can be marketed, or can result in some kind of strategic advantage for the business within a couple of months. And then you start doing that. Yes, you hire people. That has actually become a little bit easier in the last years. When I started this, my first big data science job, which is 8 years ago already, there was no market yet for that kind of AI specialists that we were looking for, but that has changed. All that has changed. So let's say you hire people, but you very, very soon run into those problems that I described earlier. So the data, they don't play along, it's hard to get them together. It's hard to consolidate the data. It's hard to clean them up because you're talking about hundreds of thousands or millions of data entries, which even with today's ChatGPT and other language models are very hard to clean up in an automated way. So there's a lot of manual labor in there and it just costs time. And that is when business owners or senior managers usually start to run out of patience and say, hey, you promised us something within 3 to 6 months. Why am I looking at a timeline of 1 to 2 years right now, plus the associated costs?
It sounds like a typical startup story, right? So like, yes, we want to change the world. I mean, we do have enough space for improvements like in the ecosystem of rail. That's for sure. And yeah, but also coming to what is your take, like how the railway looks like in 2050 and which role in your opinion AI would then play?
2050, that's far away even by railway standards.
No, it's 25 years.
Cycles are usually long. I have no doubt that AI will play a big role in the railway sector in 25 years from now, including in the area of capacity and traffic management. Independent on how things continue at Digitale Schiene Deutschland or Deutsche Bahn or Germany in general, the genie is out of the bottle, and such systems will be developed and will be implemented, will come to use. And I think they will be used in a wider context. It's not only about how to distribute limited capacity in one national or international rail network. I think, on that timeline, 25 years, we're talking about a generalized intermodal traffic optimization, because ultimately, you and I as customers, we're not interested in a specific high-speed train going from Vienna to Berlin at a specific time. We're just interested in how you can get from your door in Vienna to your meeting in Berlin. And that includes getting from your door to the nearest subway station, from the subway station to the train station, then take the fastest or the most convenient train possible, and then the same thing mirrored here in Berlin. And these things are, to optimize that in real time and maybe even give you not just the fastest or most convenient options, but integrate ticketing, and then still on the fly, in near real time, look for alternatives when something goes wrong along the way. This intermodal generalized optimization across, maybe by then self-driving electric vehicles that pick you up at Berlin Hauptbahnhof, that integrating all that stuff, that is the vision that I think by 2050 should become reality.
And if you talk about vision, but also like on a global scale, I mean, I guess you have like a huge project, that you having a lot of interesting conversations also with maybe other industry, but also other railway ways on the planet. Is there like, let's say, one country, one network, one provider who is like the absolute superhero right now in AI applications in rail? Is there some country you would mention here?
It depends. So when I think back to the last industry conferences in which I participated, when it comes to the, as I called it, the classical AI, pattern recognition, predictive maintenance, then I think the differences level out. But a few years back, there were some countries that were probably culturally more innovative than other countries. And, yes, I'd love to mention the Scandinavians here. I like their innovative spirit, yet others are not really far behind that, including ÖBB, by the way. I've seen some fascinating talks of ÖBB colleagues. Now, when it comes to capacity and traffic management, to automate, digitalize that using state-of-the-art AI, then indeed, I have to say that we at Deutsche Bahn are far ahead of others. And that is mainly, that is not only what I say about our own team, but that's the feedback we get from others. And that's the result of the recurring market analysis that, of course, some of us keep doing. And that is mainly driven by the fact that the German railway system has some problems that at this scale are sort of unique in Europe. It's a highly dense network, a completely decentralized country with stations and minor and mid-sized and large cities all over the place. Just the sheer size of the network is large, and there's a relatively high percentage of cargo traffic, and especially mixed traffic. So the cargo train that goes 90 kilometers per hour shares the tracks with the ICE train that goes up to 260 kilometers per hour or even faster. And that brings with itself some problems that on this scale are rather unique in Germany.
This sounds even like a really good and cool story, because if you also put the construction works also on the table, then basically what do you then make is basically, as you have a unique big size problem right now on the table, you solve it with AI and coming out like as a champion for the AI, having then the smoothest and the best connected railway system like in Europe. So that sounds like a really cool story.
That would be a really cool story indeed, yes.
And I think especially with AI, with the application, the incredible complexity which we have sometimes, or not sometimes, what we have in the ecosystem of rail, I think that could be really like a solution forward to tackle this complexity in order to solve another problem or to help in order to fight against the climate change. I think under this, let's say, umbrella, like the AI makes even much more sense because complexity is something which we have to deal with. It's getting more rather than less. And if we have like powerful tools and together with humans and AI, I think then we can really make the whole ecosystem for something better. And I think that that's more or less the promising what would I would like to believe that AI really helps us to make to improve the whole ecosystem.
Yes, absolutely. I agree. AI can help us to manage this complexity. And when we think of transportation as one large system composed of various transportation modes that need to seamlessly interact and integrate with one another, then AI can help to make that feasible way beyond capacity management on one isolated national network, which of course is not an isolated network.
And as you already mentioned, you have been working for more than 8 years in the field of AI, so you are already very experienced. And how comes that you are working now for DB for one of the biggest AI projects of our ecosystem? So tell us a bit more about you.
Well, I've had multiple job descriptions in my life. I started as a particle physicist, being down there in the tunnel, the accelerator at CERN in Geneva, searching for elementary particles. And I moved on to become a management consultant, where I used a lot of the concepts, structuring that I had learned as a particle physicist and apply it to business strategic analysis. I worked for one of the large companies for 3 years and then worked for my own little company, which I founded back then in Washington, D.C. in the East Coast of the U.S. For another 7 years. So I was a management consultant for roughly 10 years. Then made the step back to Europe for a number of professional and personal reasons. And soon after became an employee again. That just like the management consulting thing, it wasn't the original plan, but it sort of happened. And I was able to implement some of the ideas that I had gained as a consultant in an actual company where I faced some of the operative problems that I described earlier in this conversation. And then, with the help of some circumstances and coincidences, this program was started at Deutsche Bahn just after AlphaGo Zero, not so recent breakthroughs in AI. And they were looking for someone who understands the world of management as much as the world of technology. So a manager who understands AI and other aspects of tech. And so I was the right person at the right time in the right place.
We also learned that you're starting actually down in the tunnels in CERN, and now you are modeling to solve the big challenges and capacity issues like from Deutsche Bahn. That sounds like really like a cool step. And basically also for your personal view, like if you go a little bit outside also the railway world, coming one more back to AI, what do you see? What we can expect in a couple of upcoming years? Do you have any idea how our daily life would change? I mean, it's already started to change, but most of the experts predict that it's getting faster and much more as we expected. So what are, in your opinion, the next really big things which we can see at the AI applications?
Yes, you mentioned it, Sebastian. Some of the experts, and some of
there are so many
founders,
of them.
the forefathers, mental fathers and mothers of artificial intelligence as we know it. People with whom I will never ever compare myself, even, are sort of concerned, let's say, about what might happen next. And yes, without being at their level, I do have the impression that I share some of these concerns, or many of those concerns. Ultimately, it's not so much about the technology itself, but it's the way in which we use technology. And if we look back at the last decades, there have already been a number of technological advances that were not really anticipated decades ago. And in many cases, if you look at what came out of that, let's look at the internet. You and I, we have the privilege that we have seen basically the birth hours of the internet.
Yeah, I started with a 56K modem. Yeah.
Something like that, exactly. And IRQ rooms, chat rooms, and if you look at the promise and the mood that was existing back then, and in large part, what has become out of that, I'm rather skeptical. If we repeat the same mistakes in applying the technology, not for, but in part against the benefit of many other people on this planet, then it may really be a doomsday scenario. But of course, we are now smarter. We can look back. And people are already warning of that. So I'm in general optimistic that in the next couple of years, the decision will turn. Not the decisions that need to be made will be made in favor of applying that latest advance in technology, AI, generative AI, especially large language models, stuff that can really help us create things beyond imagination, that will really use it for something positive, for something to tackle the big problems like mobility, like environmental sustainability, like CO2, and we can use AI to help us solve those issues. And it goes back to what you said initially. If you ask AI, the answer is always AI. Yes, there's some truth in that, because let's create a somewhat more positive scenario and say, okay, yes, there's a threat, and we know the threat. The threat is that AI can produce information in a way that it looks like information, but it is actually fake news. And all it needs is a little bit of video or audio, just as we are recording right now, in order to fake someone's voice, video, etc., etc. And of course, the damage that can be created is unmeasurable. However, I believe that very soon it will be possible to use AI in order to detect such fakes. It may not be perfect, but it may serve as a deterrent. And suddenly we are in an upward spiral and say, okay, we're using the same technology that can be used against us, but we're using it for our own sake. And to some degree, that already exists. Universities are using AI to figure out if someone cheated on their thesis. So, and take that a few notches up.
So the answer to AI is always AI. Like, it's a big statement, but it's becoming true. Yeah?
And then we can harvest all those benefits that you already implied. So availability of knowledge. You type something into Google today, or your search engine of your choice, and you get an AI generated summary of the current state of knowledge on that topic. This is fantastic. So you're starting, this is the dwarfs on the shoulders of giants thing. You're starting on the shoulders of a much bigger giant than ever before. And with virtual reality, or just, simple Zoom/Teams/ whatever the tool, you can take one expert and basically make them perform some action at the other end of the world, where that action is needed right now. So just this availability and applicability of information and action in real time across the world, that will certainly help us to tackle some of the bigger issues that we have.
Absolutely. And then coming back to overall topic about RAILUP, and also the mission really to connect the people, and also to bring big ideas in front of the curtain. I think that's more or less what I really take also out of our episode. I mean, are even the big infrastructure manager working really with AI application to solve really big problems. Yeah, and this solving big problems can even lead then to have at the end of the day a much more efficient system, which basically attracts much more mobility needs for passenger and cargo. And if you use the railway as an integrated part of mobility in the best way possible, connecting with the applications, all the modes of transport, and to organize it and to react if something happens, I think that could be, or it will be really the big vision for the future.
Right. That's precisely why the railway sector is doing it. And this is also basically the founding statement of Digitale Schiene Deutschland and similar initiatives of other railway operators, It's not for the sake of automation or the sake of AI. I mean, that's a beautiful thing, but it's really done in order to increase capacity on the existing network, because building new network is time-consuming and expensive and politically prohibitive in many places. So we need to use the resources that we have, network, vehicles, etc., in a much more efficient manner to increase capacity and increase service quality. Because in the next couple of years, there's going to be a steep increase. Some studies say a doubling in passenger numbers by 2030. And then we already talked about that. We need to increase the share of rail in cargo transportation for the reasons mentioned. So all this is only possible if there can be an efficiency and capacity gain out of the existing infrastructure, and that is digitalization, and that includes not only, but it includes, of course, artificial intelligence and similar things.
That's great, and actually also great closing words, because at the end of the day, we would like to shape the ecosystem of rail into better, and that's together. And that's the spirit of Rail Up. So, Michael, welcome to the Rail Up Club.
Thank you. Thanks for having me.
The ball is in your court. What is the next step to drive change?
So I think the next steps are going to be some intensified conversations with funding agencies, mainly the government, about how to equip Deutsche Bahn, Digitale Schiene Deutschland with the means to drive this innovation to the next level and put it into production.
What is the contribution to drive climate change?
Well, I'm working now as a stakeholder manager after I have built and led the team that built the prototype until a year and a half ago. And I'm focusing on the next steps that, in my opinion, need to be done. And, I'm eager to create innovation, and I'm sure there's plenty of opportunity within the industry to create the next step, whatever that may be and whatever is needed and wanted.
Which superhero do we need to avoid the climate disaster?
Superheroes are usually a thing of movies, but since you're asking me and I'm free to have a wish, I would say my superhero would create a news media / dialogue platform organization that could counter the rather agenda-driven news media and so-called social networks that we have that make a lot of dialogue very difficult in recent years. So it would be about either agenda-free or, let's say, with a more pro-human positive agenda, give us some less biased information and make us actually debate that information in a civilized way.
What's the takeaway from this episode?
My key takeaway is that in addition to predictive maintenance, active traffic and capacity management is poised to become the next major innovation in AI applications within the rail ecosystem. I was fascinated by the complexity and holistic nature of this approach and about the project at DB, which ranges from simple tasks like optimizing train acceleration and braking to sophisticated active energy control and peak management. Incredibly, entire new schedules could be generated and implemented within seconds. However, we also learned that for full-scale applications, every part of the ecosystem must be upgraded to the latest technology standards, which could take over 10 years. Still, AI tools can already significantly enhance and accelerate operation planning today. Another key insight was that many AI projects are failing and that very often the answer of AI is AI. Overall, I believe AI has the potential to transform the rail ecosystem for the better. Let's harness this technology wisely to tackle the climate change and revolutionize mobility. And that's the Rail Up Club.
This podcast connects innovators and leaders worldwide to shape the future ecosystem of rail. Rail Up by Sebastian Sperker.